we have considered the 3D objects. Okay, the 3D objects are hemisphere, sphere, cylinder. Okay, so let us take few of the questions. Okay, now I'm taking the first question from the two question series. Okay, the first question is that even the source of these last two questions are the same. Okay, so I'm going to explain those questions over here again. Right now, let us see. A question is that a hemispherical bowl is given to you. Okay, let's say this is a hemispherical bowl. Okay, so this is a hemispherical bowl which is given to you, and it is filled up with liquid. Okay, so hemispherical ball, how it reflects like a hemisphere, right? And it will have some radius, right? Let's say this is a small r, right? And the liquid from this hemispherical bowl is poured into what? Poured into cylinder cylindrical bottles. Okay, we need to find how many such bottles will be required, right? So let us say if there are such x bottles. Okay, if all of these are symmetrical, okay, all of these are symmetrical, then we can say that this liquid will be filling up into this cylinder, right? After this, the same liquid will be filling up into second cylinder, right? And again, the leftover liquid from the bowl will be filling into the third cylinder, right? Like this, you can see the liquid. These are the liquids which are filled into it. And let us see, there are dot 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 such x cylinders will be required. So total number of cylinders which are required, we can assume it as here also liquid is filled. And in this way, when you fill the last cylinder, that is, if the total number of cylinders are x, right, cylindrical bottles, x bottles. So if there are such x bottles and the liquid from this bowl is filled up into this and all the cylindrical bottles, and here when you just filled up into the x bottle, the last bottle, okay, this liquid is filling into this also, this is filling into this also, and when this were filling into the last bottle, all the liquid from this hemispherical ball is finished, right? So I hope you understand what is happening, right? Now you can see this is a hemispherical ball, and the liquid content into this hemispherical ball will be equal to the volume of the hemisphere, right? So the volume of the hemispherical ball, or the liquid present into this hemispherical ball, will be equal to 2 by 3 pi r cube. This is the volume of hemispherical ball, and this is poured into liquid bottles, right? So there are such x bottles, we have assumed. So the volume of a cylindrical bottles, that means this is into the shape of a cylinder. So the cylindrical bottle is having a volume of pi r square h. I am using capital R over here because a small r is used for the hemispherical ball, right? So let us say for the cylinder, capital R and h are the radius and height of that cylindrical bottles. And it's given into the question that this liquid is to be filled into cylindrical bottles of radius 3 centimeter and height 6 centimeter. So R is given to you as 3 centimeter. I mean to say for cylinder, because I'm marking into the right hand side of this line. And height is also given to you, that is equal to 6 centimeter, right? So as we said and discussed, the liquid from this bowl is poured into all such bottles. So whatever the volume of the liquid present into this bowl will be equal to all the liquid present into these bottles. And when you add up the all the volumes of this liquid, all these volumes will be equal to the volume of this hemispherical bowl. So we are writing volume of liquid present in bowl will be equal to x such bottles. So x will be multiplied with the volume of one bottle. Volume of cylindrical. Hi, super duper Nikad. Love you. You love maths? I also love it, man. Thank you so much for connecting. Bye bye. Take care. Oh, no, no, welcome. It's not the time to say goodbye. Yes. So the volume of the liquid present in bowl, this bowl, is equal to x times the volume of cylindrical bottle. I mean to say the liquid present into the cylindrical bottles, right? So you just write up the formula as we said 2 by 3 pi r cube. So 2 by 3 into pi. But for the hemispherical ball, it's given that hemispherical ball of internal diameter 36 centimeter. So that means the radius will be half of the diameter. So it will be 36 by 2 will be the radius of this hemispherical ball, right? So 2 by 3 pi r cube, this will be the liquid volume of the liquid present into the bowl, and this will be equal to x number of bottles times the volume of each of the liquid present in each bottle, right? So x into pi r square h, this volume, right? And what is the value of pi? Pi will be as it is. R is given to you as 3, so this will be 3 square into h is given to you as 6 into 6, right? Here just solve it. Pi and pi will be cancelled out, whatever else you can cancel. Okay, let me see whatever else we can cancel. So just write the value of x first. So it will be 2 by 3 into 36 by 2 is 18, so it will be 18 into 18 into 18, which is equal to x into 9 into 6, right? Here also, from 9 you can cut 18 in 2 times. From 6 you can cut 18 in 3 times, right? And this 3 in the denominator will cancel out this 3. So this 3 will be cancelled, and this 2 into 2, 4. 4 into 18 will be the value of x. So 4 into 18 is the value of x. So we are getting 72. 4 at 32, so 72 is the value of x. So we need such 72 cylindrical bottles so that all the liquid present into this is hemispherical ball will be emptied over here, right? So total, I am writing the answer. So total 72 such bottles, 72 cylindrical bottles will be required to empty the liquid of hemispherical ball. I am pronouncing along with writing, so that if my handwriting is not understandable to you, you'll be able to understand. Okay, so we need such bottles, such 72 bottles, so that the liquid present into this hemispherical ball will be emptied into these cylindrical bottles. And you know, when you fill up the last xth bottle, right, then all the liquid present into this hemispherical ball will be finished, right? So what we did, we just calculated the volume of the liquid present into the hemispherical ball and equated with the volume of the liquid present into the ball and equated with the volume of the cylindrical bottle. And since such x bottles, so the total volume work will be added x times, so it will be x into pi into 3 square h, right? We know the volume of a cylinder is pi r square h, and volume of a hemispherical bowl is 2 by 3 pi r cube. We just use that formula to calculate the value of x, and we get the value of x as 72. So we can say total 72 cylindrical bottles required will be required to empty the liquid of the hemispherical ball. Sorry. So students, I hope you like the solution. Now let us come to the second question. Okay, what was the second question? The second question is also from the three-dimensional mensuration. Okay, it's given that the volume of two spheres and are in the ratio 64 is to 27. So first of all, you need to understand a sphere. What is a sphere? A sphere is looking like this. Okay, a sphere is looking like this, right? So if this is a sphere, the question is that there are two spheres, okay, and the ratio of the volumes of those spheres are given to you. Let us say this is a sphere 1, this is a sphere 1, and let us say this is a sphere 2. I am writing it over here. This is a sphere 2. So two spheres are given to you, okay. This is a sphere number 2, okay. Now it's given that the volumes of the two spheres are in the ratio 64 is to 27. So we can say that, let us say for the bigger sphere the radius of the sphere is capital R, and for the smaller sphere let us say the radius of the sphere is small r, right? Now what we can do, we know the volume of the sphere. Volume of the sphere, volume of a sphere can be written as 4 by 3 pi r cube, isn't it? Where r is the radius, so when it r can be capital R also and a small r also, right? Now it's given that volume of the sphere is 4 by 3 pi r cube. Not into the question, but you need to remember this formula, right? Now it's given that the ratio of the volume of the bigger sphere, that means volume of a sphere, ratio of the volume of a sphere, that means volume of a sphere 1, that is this much, to the ratio of volume of a sphere 2 is given to you as what? It's given to you as 64 by 27. So this is the data as given to you, right? Now you need to find what is the difference of their surface areas if the sum of this their radius is 7 centimeter. Then it's given that it's given this sum of this radius, that means capital R plus a small r, it's given r plus r is 7 centimeter. So this is one of the relation which is available to you, right? This is one of the relation which is available to you, that is the radius of both the spheres, and sum of that radius of both the spheres is given to you as 7 centimeter. And what is the second data which is given? We need to find the difference of their surface areas. If the difference of the surface areas, you need to also remember one of the formula from a sphere, that for a sphere the surface area is what? 4 pi r square, isn't it? Surface area of, this is the formula for surface area of a sphere, right? And we need to find the value of difference of the surface areas, that means 4 pi, the r will be capital R for the bigger sphere. So this will be the surface area of, this is the surface area of sphere 1 minus 4 pi small r square. This is the surface area of sphere 2. So what will be this value that we need to calculate? This is the question which is asked into our question. This is asked, right? So what is the difference of the surface area that we need to find? Okay. So this we need to calculate. So I am just marking it with a separate color so that you will be able to understand, right? Now first of all, r plus r is given to you as 7 centimeter, right? Now you can see the volume of the sphere 1 by volume of sphere 2, this ratio is also given to you. So just use this ratio, use this step, use this given data. That is the volume of a sphere 1 will be equal to 4 by 3 pi into r cube. Here r will be capital R, mark it, divided by 4 by 3 into pi into a small r, because the volume of a sphere 2 is into the denominator, this one. This data is given to you as equal to 64 by 27. Now solve it. 4 by 3 pi and 4 by 3 pi will be cancelled out, and we are left with r cube by a small r cube, right? So we can write it as a small r, capital R by a small r whole cube, because both are cubes, is equal to 64 by 64 by 27, which can be written as 4 into 4 into 4 by 3 into 3 into 3. 27 can be factorized as this, and 64 can be factorized as this. So we can write the RHS as 4 cube by 3 cube, or we can write 4 by 3 whole cube, isn't it? Now take the cubic root into both sides of the equation, right? When you take the cubic root in both sides of the equation, mark it, this is cubic root, right? We are taking power of 1 by 3, and that will be multiplied, so this will cancel out this 3. So we get the value of r by r as equal to 4 by 3. So this is another relation which is derived, right? This is the another relation which is derived. So this was equation number 1, right? And this is equation number, this was equation number 1, and this was equation number 2. Now we will be using one of the formula, that is what? We will be using the formula of a plus b whole square and a minus b whole square, right? Why we will be using it? Let us see. Now, because we need to calculate the area of the both the volume difference of the surface areas we need to calculate. So before going into that or using any formula, why don't you just put up the value of r from here into this? Let us see. From here we can see capital R can be written as 4 by 3 times a small r, isn't it? Capital R can be written as 4 by 3 times a small r, right? And this relation can be used into equation number 1, right? So in equation 1, r plus r is given to you as 7, right? Sorry. So in place of r you can write 4 by 3 times a small r. So we can substitute the value from equation 2, that is 4 by 3r, using the value of r from equation 2, putting the value, substituting the value of capital R and this small r equal to 7. So this will give you, so this is basically, this step is taken from equation 2, value of r is kept, this. So when you solve it, 3 plus 4, 7r equal to 21, right? So this will give you the value of a small r as 21 by 7, which will be equal to 3 centimeter. So the value of a small r equal to 3 centimeter is calculated over here, right? Now when you put up this value into this equation number 1, you get the value of capital R. So what will be the value of capital R? It will be 7 minus a small r, which will be coming as 7 minus 3, which will be coming as 4 centimeter. So r equal to 4 centimeter is calculated over here. So here you can see r equal to 4 centimeter, which is calculated, right? Now It's we are required to find the difference into the surface areas of both the spheres, right? So 4 pi r square minus 4 pi capital R square minus 4 pi small r square is the value or the difference of the surface areas, and this value we need to calculate, right? Since we have calculated a small r, we have calculated capital R, it's very easy, and we are almost at the end of the question. We are about to solve it completely. So just I'm writing the values over here and using this difference in SA. SA means surface area. I'm just using the short term. Difference in surface areas can be calculated as 4 pi into r square minus small r square, isn't it? So it can be written as 4 into 22 by 7 into r square minus small r square. What is capital R? It's 4. So 4 square r square will be 4 square will be equal to 16, isn't it? And when this small r will be taken, this small r square will be 3 square is equal to 9, isn't it? So 16 minus 9, 16 minus 9 here will be 7. So just 7. Here you can see 7 and 7 will be cancelled out, and 22 into 4 is 88. So 88 is your answer. 88 is the difference in surface area of these two spheres, that is calculated as 88. So 88 is the difference in surface area. I am writing SA. Okay, is difference in surface area of both given spheres, right? So in this way our answer is calculated, that is 88. And what will be the unit of 88? Since its area, it's 88 centimeter square, right? So 80, this will be coming as, this answer is coming to you as 88, this is 88 centimeter square, right? And in this way we have solved this question. I hope you liked today's session, students. If you find it useful, you can like it. Thank you so much for watching. Happy learning. Bye bye. Take care. And don't forget to go through the playlist in my channel where selected questions have been solved and just recorded over there. It will definitely help you at some extent, and definitely on the top your efforts are there, because your efforts only pays for, and I can only help into just your improvement. If you want to, you can just go through the different sections and just put up your hard efforts to get the result. Thank you so much for watching. Happy learning. Bye bye.